So there is no single technique that is best for all purpose. Here is a summary of the relative advantages and disadvantages of the main techniques, which is given in the table. So with regards to the sensitivity of the flame absorbance spectroscopy, it is only moderate. Sensitivity is excellent in the graphic furnace absorbance. This is a flameless. Excellent also can be seen in the ICP-MS or inductively coupled plasma mass spectroscopy. For the AES or atomic emission, this will be moderate for the ICP-AES. With regards to selectivity, we have poor under the ICP-AES or atomic emission spectroscopy. We have an excellent selectivity under the flame absorption. With regards to moderate coverage, we have excellent for the ICP mass spectroscopy. We have moderate for the flame absorbance. Speed for 1-allanite, we have the fast for the flame absorbance, for atomic emission, and for mass spectroscopy, wherein we have a slow under the graphic furnace. For multi-element capabilities, flame absorption is not multi-element. Graphic furnace is not multi-element. For our ICP-AES or atomic emission, yes, it has a multi-element capability together with the ICP-MS. Initial cost of the instrument, we have low cost for the flame absorbance and a very high cost for the ICP-MS or a mass spectroscopy. For the cost of the consumables, we have a very low cost for the flame absorbance, very high cost for the graphic furnace, low cost for the ICP-AES, and for the mass spectroscopy, moderate cost. Ease of operation is excellent for the flame absorbance, and we have a poor ease of operation for the graphic furnace. We have moderate for the atomic emission and for the mass spectroscopy. Let's now talk about the interferences. Interferences are factors that hinder or impedes a procedure. In general, the interferences in the element analysis are classified as spectroscopic or non-spectroscopic. Pag sinabi nating interference, ito yung pwede na nagpapabagal or bumabalakid or obstacles in performing the procedure. The first one under the spectroscopic is spectral overlap. Spectral interferences generally result from a spectral overlap. Ayan, kung nakikita po natin, meron pong mga overlapping sa ating pong mga samples. So this is one of the interferences or hindrance para mag-produce tayo ng mas accurate na result. For example, in the atomic absorption spectroscopy, the molecular species may have a broad absorption spectra that may overlap the line spectra of the element of interest. Ayan, so nag-overlap nga po sila. A much less common occurrence would be for the absorption spectra of one element to overlap with that of the other. Ayan. Now, paano po natin madidil itong ganitong interference? So, we have a continuum source background corrector. So, ito po ang isa sa mga paraan para maiwasan natin itong spectral overlap. It may be included in the instrument design at the cost of some instrument complication. Another, para po maiwasan natin itong spectral overlap, is the use of the Zeeman background correction. This relies on shifting the atomic spectral lines by the application of a magnetic field. Then we have the second spectroscopic interference, polyatomic ions. Ayan. So kung titingnan po natin yung mga polyatomic ions, kumbaga, merong instances na pare-pareho sila ng charges. Diba? So, for example, you have your copper ion, we have the copper 2, your ferrous, ferric, diba? Lead, so lead 2, lead 4. So, itong mga to, mga polyatomic ions. So, we have a particular element with different sets of charges. So, we have here in the ICP-MS, spectral interference, madalas na na-encounter niya na interferences are the polyatomic species whose, okay, yung pong MZ ratio po nila, so yung pong, again, pagka sinabi po natin yung MZ ratio, this is the charge to the ion ratio, sila naman yung nag-overlap. Now, ito po yung mga ways para ma-deal natin yung pag-overlap ng mga polyatomic ions. One is to apply algebraic equation together with the relative isotopic abundance information in order to mathematically correct the interference. The second thing that we will do is that we may use a reaction cell or a collision cell between the main ion lenses and the mass analyzer. Next, we may also use a small amount of gas such as helium or ammonia that is introduced into the cell, which removes the interferences. This is either by a chemical reaction or by a energy filtering process. Using the fact that polyatomic species with the larger collisional cross-sections lose energy faster than the atomic ions. Ayan, para po maghiwalay yung mga ions ng iba-iba pong mga species. Gagamit tayo ng mga gases such as helium and ammonia in order to remove the interferences. High-resolution mass spectrometer may also give a solution in order for us to avoid these polyatomic ion interferences. Then we have the spectroscopic, specifically isotope of the nearby elements. Ayan. So kung titingnan po natin yung example natin dito, nandyan po yung tin at saka si cadmium. Makikita mo yung isotope po ng tin natin is 114. Same as true with the isotope of our cadmium, which is 114. So pwede po silang mag-overlap ulit, di ba? So this will again become an interferences. The source of the spectral inferences is the one that arises from the nearby elements in the periodic table. Yung mga magkakadikit-dikit na elements, ayan, ito po yung mga isotopes nila. For example, just what we have mentioned a while ago, yung tin po natin and cadmium have both isotopes that are found at 114 atomic mass unit o yung Da. So, pwede po silang mag-interfere sa bawat isa with regards to their charge ion ratio. So, paano natin gagawin ito? Siyempre, this will be handled by using a different type of isotope for analysis. So, tingin tayo ng isotope na wala silang pareho para maiwasan ang mga interferences. For example, tingnan natin yung ating pong isotope sa cadmium. Okay? Yung isotope cadmium po natin, kung titignan natin na, ito meron siyang 111. Okay? So, with regards naman kay tin, wala siyang 111. So, yun ang pwede po natin gamitin para ma-avoid po natin yung isotopes of nearby elements. So, pwede tayong gumamit na wala doon sa pareho nilang isotope. So, this is your cadmium 11. So, kung titignan mo yung tin, wala siya. Diba? So, that is one way in order to solve and prevent these isotopes of nearby elements. Then we also have the non-spectroscopic interferences. So, one of the most common non-spectroscopic interference is the matrix interference. Matrix interference involve the bulk property of the sample. Ito naman, pagdating sa matrix, ito yung attributes or qualities ng ating specimen. Ayan, viscous ba siya? Diluted ba siya o watery? So itong mga to ang kino-consider natin na pwede pong mag-cause ng interference habang kinukuha po natin yung ating pong trace element. The aqueous sample may behave differently than the organic and the biological specimen, depending upon the technology used and the analyte of interest. The property, kagaya po na nabanggit ko kanina, isang factor ito. Baka hindi sila pareho ng viscosity, yung sample and the standard that we used. Presence of easily ionized ion and the presence of carbon. Matrix matching of calibrators, controls, and specimen helps overcome the matrix interference. Ayan. Kung alam natin na magkaiba pala yung ating pong viscosity doon sa ating pong gagamitin na control or standard, then mas maganda po na pareho sila. Kaya tinatawag silang matrix matching. So in order to avoid interfering with the physical attributes or physical properties of our specimen, mas maganda na pareho sila. Okay? Para mas maging accurate yung makuha po nating result. Dilution of the specimen helps minimize the matrix effect, but it is only applicable to certain analytical technique and to the determination of the analyte with higher concentration. Anything that would interfere with the atomization of the sample could be classified as the non-spectral interference. Ano-ano tong mga to? For example, in the atomic absorption spectrometry, a flame may not be hot enough for efficient atomization. So, syempre, kung hindi enough yung flame, hindi po magiging gas particles, hindi magiging atom yung ating pong mga sample. Therefore, it would interfere, diba, with the reading of the result. Another is the difference in the sample viscosity between the standard and the unknown sample resulting in different rates of the sample. Kagaya na nabanggit ko, kung hindi po pareho yung characteristic na viscosity ng ating pong sample and that of the standard, then possible po na magkaroon ng interference or inadequate po yung magiging result ng test natin. In emission spectroscopy naman po, anything that would prevent the efficient excitation or emission of spectral lines used for analysis would constitute a non-spectral interference. Now for the elemental speciation. So, napaka-importante po na tignan po natin kung ano yung level of toxicity ng bawat elements natin. Meron kasi mga ibang mga elements na kung saan po meron siyang toxic form and non-toxic form. So, for example, nandito si arsenic. Ayan, si arsenic. So, meron siyang non-toxic form at ang tawag natin sa non-toxic form niya is arsenobetaine. So, this is the non-toxic form of arsenic. So, meron na pong papunta sa toxicity, okay, kapag methylated form na yung arsenic natin. Kapag meron na pong methyl na naka-attach, then this would mean that it already has a intermediate o papunta na siya sa toxicity dahil ang pinaka-toxic po are the inorganic arsenic such as arsenic 5 and arsenic 3. These are highly toxic. In the medical evaluation of patients, it is important to know, kagaya ng sabi natin dito sa elemental speciation, na ano bang klase ng form ng element ang present o na-absorb ng isang pasyente. Is it the non-toxic form? Is it the intermediate form? Or is it the highly toxic form? Ayan, Nena. For example, with regards to our arsenic in the medical evaluation, so dito, yung elevated arsenic level, Nena. So tinitignan natin gaano ba katagal, diba? Gaano ba katagal kapag maging toxic level siya? O ano bang klase yung na-absorb sa kanya? For example, yung seafood, na merong arsenic na ingest up to 3 days. So pwede itong mag-form at pwede po itong mag-develop further into a dangerous one. Ayan. So, depending on the length of time na nasa tao na po siya. So, this would become the inorganic arsenic form. In addition, the concentration of the methylated forms may also give us a useful information in monitoring the recovery from the toxic exposure. Pag kasi sinabi po natin ng methylated form, eto papunta na siya doon sa toxic level. Kaya napaka-importante na alamin din po natin kung anong klaseng form ang na-absorb sa patient. Next, we have the hyphenated technique that uses ICP-MS or liquid chromatography and at the same time, inductly coupled plasma mass spectroscopy. So, pinagsama sila. Ne? So, kung titingnan ninyo, these are instruments that are combined. Nenak. So, ang tawag natin kapag pinagsama po natin sila, hyphenated technique. Okay, so the so-called hyphenated technique allows for spatial determinations. This is a combination of two or more complementary analytical technique that is used to measure a specific form of an analyte. A classic example of the hyphenated technique is your ICP-MS or the liquid chromatography inductly coupled plasma mass spectroscopy. So dito po, the sample is injected into a liquid chromatograph which then separates the different chemical forms of the analyte producing a characteristic retention time. Ayan. So yan po yung gagawin ng ating pong liquid chromatography, yung retention time. At the same time, the eluting sample is continuously analyzed by a mass spectrometer. Now, in here, sa dalawang instrument po natin, the retention time will be identified by the analyte through the liquid chromatography, and then it will be further identified by the ICP-MS or by our inductly coupled plasma mass spectroscopy. So yan po yung dalawang gagawin sa hyphenated technique. Pagkakuha sa retention time sa liquid chromatography, it will be further identified into a most specific instrumentation, and that is the ICP-MS. In some cases, the atomic absorption spectroscopy may also be a substitute for a mass spectroscopy in elemental speciation schemes. Methods for elemental speciation are now common, most especially in the Europe. Despite the clinical matrices being among the most difficult for speciation, several applications are reported, and these are as follows. Ayan. So for arsenic speciation, ang ating pong ginagamit ngayon is your liquid chromatography ICP-MS and also HG o yung tinatawag po nilang hybrid generation, graphic furnace absorption atomic absorption spectroscopy. Ayan. For the copper naman, so this makes use of a urine by making use of the SEC o yung tinatawag po nilang size exclusion chromatography. And again, kasama po ng isa pang instrumentation which is the ICP-MS. Copper in the red blood cell may also be determined making use of the size exclusion chromatography and the ICP-MS. Lead in the blood may also be determined by making use of this time naman po, gas chromatography, and it is also together with that of the GFAAS or the graphic furnace atomic absorption spectroscopy. Selenium naman, ito by making use of two instruments, we have the size exclusion chromatography and the graphic furnace absorption, atomic absorption spectroscopy. We also have the zinc in the urine by the anion exchange chromatography, ICP-MS. So kung titingnan po natin, majority po sa ating po mga hyphenated technique makes use of a spectroscopy and coupled with that of a chromatography. So napansin niyo marami po siyang mga chromatography, usually liquid chromatography and that of the gas chromatography, including the size exclusion chromatography. Tapos noon yung kanya pong kasamang isa pang instrument is it's either atomic absorption or it's either a mass spectroscopy. So yun po yung mga karamihan pong ginamit po nila dito sa nabanggit na mga hyphenated technique po natin. So we also have the alternative analytic technique. So this is an example of a alternative analytic technique. So ano kayang aparatos ito? We have the voltammetric method. Ayan. So the voltammetric method makes use of a anodic stippling voltammetry. Ayan. And a absorptive stippling voltammetry that can be used in the determination of selective metals for a point-of-care device. So pag sinabi po natin ng point-of-care, mas friendly siya sa ating mga patients. Mas mabilis po siyang gamitin, mas mabilis yung pag-release ng result. So mas kumbaga sa yung turnaround time niya mas mabilis. Ayan, nena. So, we have the point-of-care devices that are considered the new generation of a more compact instrument that are more automated and more user-friendly. So, kagaya na nasabi ko, mas madali siyang gamitin. So, these may also be available beside the patient or for bedside testing, screening project, wellness center. Kaya kung titingnan po natin, ang dami-dami na po mga skincare clinic dyan sa ating pong mga lugar, because of the point-of-care devices. These can also be seen in the emergency room, operating room, and even in the clinic. Most of the point-of-care device chemistry analyzers uses samples that are less than 50 microliters in volume and kaagad po nating makukuha yung result niya with a turnaround time that is less than 10 minutes. Ayan. So yan po ang isang example po ng ating pong anodic stippling voltammetry kung saan meron siyang glass support, a metal support, the rings, and then the gold-plated pins with the electrode array platform. Again, ang kagandahan po dito sa alternative analytic technique natin, mas mabilis silang gamitin, mas user-friendly po sila at mabilis na lumabas ang result. Then we also have here ion chromatography. Ayan, So, nandyan na naman po yung chromatography natin. So, parang kamukha siya ng hyphenated technique. But this time, the ion chromatography can be used for the determination of the following important elements. We have copper, iron, zinc in the serum, and in the blood, and in the plasma. And it is also used in the determination of zinc in the urine. Gas chromatography, mass spectroscopy is again an alternative analytic technique that is capable of determining trace elements such as cadmium, chromium, cobalt, copper, lead, and selenium that is found in the urine. Copper may also be found in the serum and lead that may be found in the blood. The methods of accommodating direct analysis of solid samples, for instance, we have the laser ablation. Ayan, ICP-MS. Ayan, so, kumbaga, titingnan na naman natin, dalawa na naman siya na technique. So, you have your laser ablation o yung LA, ICP-MS, inductively coupled plasma mass spectroscopy, are gaining recognition for selected clinical applications. So itong mga to, mas mabilis po silang mga ginagamit. So kung titignan natin, ayan, si ion chromatography, ayan, we have here that is used to determine several trace elements, followed by the gas chromatography. So ito pong nasa picture natin is an example of a gas chromatography. Ito po yung mga essential parts niya. Meron siyang gas tank, pressure regulator, flow controller, and then we have the sample injection port, Ito po yung column po niya with that of the detector. Then we have the column oven. Ayan, dito po nakatago po yung column natin. And then we have the processor signal, the outlet. Ayan, yan po yung parts ng ating pong gas chromatography. Essential trace elements, ito po ay napaka-importante sa atin po dahil ito ay kailangan para sa important process. Kagaya po na nabanggit natin before, these are essential in the enzyme process. They are also essential for the production of oxygen, doon po sa ating pong hemoglobin iron sa red blood cells natin. Another thing that we have to consider for the essential trace element is that they are also responsible for helping our mitochondria in the electron transport chain na nabanggit natin kanina. So, essential trace elements na napaka-importante po dito, uumpisahin po natin si copper at saka si iron. So, when we talk about copper, this is an essential trace element that is present in all the body tissues. A small amount of it is needed for the body to function, but the body cannot make its own copper. Kaya napaka-importante na kuhanin po natin yung copper sa pagkain. Followed by iron. So, iron is considered essential mineral because, kagaya po na nabanggit natin kanina, it is needed to make hemoglobin in certain parts of the cell. Next, we have the selenium. This is an essential component of various enzyme and proteins. Kaya nga po tinatawag siyang selenoproteins. So, these help make DNA and protect against cell damage and infection. We're also going to talk about the zinc, which is an important trace mineral. So, ito pong zinc natin is a major player in the creation of the DNA, growth of the cells, building of the proteins, healing of the damaged tissues, and of course, most importantly po, is the healthy immune system. So as we all know, my dear students, di ba na, yung ating pong vitamin C, mas maganda, mas malakas kapag sinamahan natin ito ng zinc. So, eto, makikita natin na isa sa supporting function po niya is to have a healthy immune system. Mas malakas ang immune system kung yung ating pong ascorbic acid ay linagyan pa natin ng essential trace element, and this is the zinc. We're also going to discuss the non-essential trace elements, namely arsenic, lead, and mercury. First, we are going to talk about copper. So, mag-define muna tayo ng terms. Kapag sinabi po natin ng sequestration, napaka-importante nito sa role na gagampanan ng copper. So, ano bang ibig sabihin ng sequestration? So, this is the removal or isolation from the rest. Kung makikita po natin ang ating pong picture, makikita natin dito na itong isang robot, tinago niya, okay, yung lahat ng carbon. Ayan, sabi, carbon capture, emission to zero. Ayan. So, this is also in relation to our copper. Ayan. Sequestration. So, makikita natin mamaya kung gaano ka-importante yung copper with regards to sequestration. Ano ba yung tinatago niya? Ano ba yung aalisin niya? Ayan, di ba? So, that is important for the discussion of copper. Another definition of terms, ayan, so kung makikita po natin, we have ceruloplasmin. This is an alpha-2 globulin that binds to 95% of copper. It is also a peroxidase enzyme that in human is encoded by the CP gene. Ceruloplasmin is the major copper-carrying protein in the blood, and in addition, it plays a role in iron metabolism. So, una-una, tingnan po natin yung nasa picture. Si ceruloplasmin, para siyang sasakyan. Ayan. Sino ang nasa sasakyan? Si copper. So, kung titingnan natin, ang function ng sasakyan is for traveling. So, ibig sabihin, service, ibig sabihin transport. Siya ang nagdadala sa copper natin from the different organs of the body. Ayan, Nena. So, si ceruloplasmin. Isa pa na function ng ceruloplasmin natin, kung titingnan po natin dito sa ating pong definition, is, ayan, kasama din po niya si iron. Ne? So, lalong-lalo na po when it comes to the peroxidase enzyme. Ne? This one is related also to ceruloplasmin. So, dalawa na trace element ang siniservice niya, ang sinasakay niya at hinahatid niya sa iba-ibang mga organs. Siyempre, pinakamarami ang ating pong copper, followed by the iron. Ayan. Kaya nga po sabi dito, yes, majority is copper carrying ang ating pong ceruloplasmin, pero it also plays an important role in iron metabolism. These are the different sources of food of copper. So we have oyster. Ayan. So mataas po sila sa copper. And shellfish, including the whole grains, beans, nuts, potato, and organ meats. Green leafy vegetables such as those also of the dried fruits na prunes, kokwa, black pepper, ayan. So kung titingnan po natin ang copper, this is the most abundant trace element in the body. It participates in cellular respiration. So nabanggit natin kanina sa biological functions, di ba na, kung saan meron pong mga important trace elements that help in the processing of the most important energy, which is the adenosine triphosphate, Nena. At eto na, nakita na po natin kung sino po ang tumutulong sa ating pong mga trace element, si copper. Okay, so copper is also important in helping the powerhouse of the cell, which is the mitochondria, doon po sa pagpoproduce ng ating pong adenosine triphosphate. It is also essential for the DNA and RNA reproduction, maintenance of the cell membrane integrity, and ayan, nakita na po natin ang word na sequestration. Ang ibig sabihin ng sequestration, tinatago niya ang free radicals. So kung pag-uusapan natin ang free radicals, ito po ay mga cells kung saan po sila ay kulang ng electrons. Ne? Anong mangyayari dito sa mga free radicals na to? Itong mga free radicals na to, kukuha sila sa ating mga normal cells. As a result, magiging incomplete yung mga electrons ng ating pong mga normal cells and they will undergo oxidation. So kapag na-oxidize yung ating pong mga cells, ibig sabihin they are going to lose electrons. And what happens? Mas-stress itong mga cells na to hanggang magkaroon tayo ng iba't ibang mga sakit. Then, this will also lead to aging. It will also lead to possible cancer formation. Ang dami pong mga effect ng ating pong free radicals, lalo-lalo na kapag tayo po ay na-expose sa mga iba-ibang mga environmental factors. So, anong gagawin ng ating pong copper? Aalisin niya ang mga free radicals. Yeah? Isi-sequester niya. Yan, itatago niya ang mga free radicals. Ayan, Nena. So, kumbaga, kung titingnan natin, ikukulong niya sila para hindi sila, tuluyang manira ng iba't ibang mga cells, lalong-lalo na po yung mga healthy cells natin. So, that is the important function of our copper. So, copper is distributed in the liver. It has the concentration of the copper, highest concentration nito na. Then, copper, pag lumabas yan sa liver, ayan, so nandyan si ceruloplasmin, di ba? So, alam naman natin kanina, si ceruloplasmin, yan yung pinakasasakyan niya o yung tinatawag nilang transport protein, para ma-distribute ito sa iba-ibang parts ng katawan. Ceruloplasmin also act in mobilization of the iron in the storage sites. So, it functions as a peroxidase enzyme during the ferrous to ferric conversion of iron. So, eto po, ang clinico-pathologic correlation na makikita natin kapag meron tayong copper. Okay? So, particularly, ano pong condition nito? Copper deficiency. Ang pangalan po nitong copper deficiency na to is Menkes disease. Ayan. Ang copper deficiency, na-observe ito madalas sa mga premature na bata o kaya yung mga ibang mga contributing factor o yung mga risk factors, yung mga merong osteoporosis at merong sakit sa puso. Now, what is all about the Menkes disease? This is otherwise known as kinky hair syndrome. And there is a profound decrease in ceruloplasmin level and copper level. So dito, mababa po yung kanya pong ceruloplasmin at yung kanya pong copper. Lalong-lalo na sa buhok, kaya nagkaroon siya ng kinky hair niya kasi konting-konti po yung components o yung contents ng ating pong copper pagdating sa buhok nitong batang merong Menkes disease or kinky hair syndrome. There is also the presence of truncal hypotonia. Ayan, so kung titingnan po natin, no, Nena, so hypotonia or the loss of the muscle tone, so hindi po niya kayang buhatin yung sarili niya dahil dito. Now, the one that is responsible for generating Menkes protein is the ATP7A gene. Then, this is also described as a rapid brain atrophy predisposing to subdural hematoma. So, affected din po pati yung brain development. Sparse kinky hair. Ayan, so kung makikita po natin yung mga buhok, hindi po sila evenly distributed at kinky po yung mga yan. Next, we have Wilson's disease. Ayan. So kung titingnan po natin ang Wilson's disease, meron siyang mga distinguishing characteristics. Now, this is all about copper toxicity o yung sobra naman po na pagdami ng copper sa katawan natin. This is characterized by increased tissue serum and increased tissue and serum level of copper. So, acute copper poisoning may be caused by ingestion of excess copper, fungicides that contains copper sulfate, or exposure to industrial sources. Ito, sa pagdami po ng ating pong copper, meron tayong tinatawag na Wilson's disease. Ayan. So, ang Wilson's disease, tinatawag din po siyang hepatolenticular degeneration. This is a rare autosomal recessive disorder of copper metabolism. And ayan, so yung mga manifestation po niya, there is a impaired excretion of copper in the tissue including the liver, brain, and cornea. So, tingnan po natin ito, Nena. Ayan, so makikita natin dito, pwede siyang magkaroon ng liver cirrhosis. Pagdating naman po sa brain, ayan, affected po yung paglalakad niya. So, the gait appearance niya o yung walking, makikita natin yung para siyang merong Parkinsonism. And then also that what is important here is the Kayser-Fleischer rings kung saan makikita po natin sa mata. Ayan yung sobra-sobrang copper na nakapaikot po sa mata ng patient na merong Wilson's disease. So again, the Kayser-Fleischer ring, this is a common ophthalmologic finding in the eyes that is due to the accumulation of copper. Now, so dito nga po, kagaya na nabanggit natin, serum copper is elevated in patient with Wilson's disease. Next, we have the analytical methods for copper. Serum and urine copper is measured by the following. Of course, we have the atomic absorption spectroscopy, which is the method of choice. We may also have colorimetric method, wherein the ceruloplasmin is measured by photometric and immunochemical methods such as nephelometry. So dito po makikita natin yung ating pong copper from the serum and iron, pwede daw po natin siyang i-determine, i-measure, making use of the two important instrumentation. We have the atomic absorption spectroscopy and the colorimetric method. Kung gusto naman po nating tignan ng ceruloplasmin, this is the transport protein, di ba nak, that carries our copper, then we may make use of the photometric method and the immunochemical method such as the nephelometry. Next, we have iron. Let's first discuss the important terms associated with iron. The first one is transferrin. Ayan. It is a single-chain glycoprotein that is synthesized in liver. Ayan. So kung titingnan po natin yung ating pong illustration, bawat isang transferrin, kaya niyang bigyan ng upuan yung dalawang iron. Ayan. So kung titingnan po natin, imagine natin ang transferrin para siyang seating capacity. So transferrin can accommodate 2 iron. Ayan, dalawa pong atoms ng iron ang kaya po niyang i-accommodate. Transferrin. It binds with ferric ions with high affinity. So, nakita po natin si transferrin. Ito niya naman ay ferritin. Ayan. Ferritin is found virtually in all the cells. It provides accessible reserve of the iron for the synthesis of the functional iron-containing compounds. Si ferritin, para siyang kahon. Okay? Kumbaga sa kahon, marami siyang stored na iron sa loob. Ayan. So, kung titingnan po natin yung ating pong illustrations, ayan. So, dun sa loob ng kahon, marami siyang stock of iron that is present. Para kung biglaan mangailangan tayo ng iron, then kukuha si ferritin at bibigyan ng katawan natin. Ayan. So, again, one of the important function of the ferritin is that it provides accessible reserve of iron for the synthesis of iron compounds. Ayan. So, they are present in the stack of boxes. It also serves as a means of sequestering iron in a soluble, non-toxic form. Ayan. Ang ferritin, pwede rin daw niyang itago yung sobra-sobra naman na iron in a non-toxic form. Ayan. Usually, sa hematology natin, di ba meron tayong mga red blood cells na kapag sila po ay nag-rupture o na-hemolyze, lalabas yung ating pong biliverdin, then bilirubin, and then yung ating pong iron lalabas. So as a result, ito pong iron na ito mag-i-store siya sa katawan natin. And ngayon, anong ginagawa doon sa excess na iron na yon na napoproduce? Siyempre, i-recycle natin yan. I-recycle natin with the help of ferritin. Ayan. So, si ferritin, again, gagamitin natin ulit yung iron na nagamit sa mga namatay na red blood cells, diba? Dahil 120 days yung lifespan nila. So, after 120 days, it will disintegrate and as a result, lalabas yung iron content. So, syempre, importante po ang iron natin. So, hindi ito lalabas ng katawan. Instead, ito po will be stored in the form of ferritin. So, kukunin ni ferritin at itatago niya. Kapag mangangailangan tayo ulit for the production of red blood cell, bibigyan tayo ni ferritin kasi marami siyang stock. It is a measurement of great value in detecting iron deficiency anemia because it occurs early in its development. Increased serum iron ferritin is observed in the following conditions such as fever, acute infection, rheumatoid arthritis, and also viral hepatitis. Kung makikita po natin ang ating pong picture dito, pag tinatago natin si iron, nandyan si ferritin. Ngayon, kung gusto naman pong i-distribute yung ating pong iron palabas, okay, palabas, then gagamitin natin si transferrin. Okay, so transferrin, ayan. So again, this is a transport protein that will, kumbaga parang sasakyan siya, di ba? Ita-transfer niya, imo-move niya, ita-transport niya yung ating pong mga iron sa circulation. There are different sources of foods that is found in iron, namely the nuts, fruit, pasta, iron-fortified bread, cereal, legumes, oats, tofu, spinach, raisin, apricot, meat, and chicken. These are sources of iron. So, iron is the most abundant metal in the human body, with a concentration of approximately 40 to 50 milligrams of iron per body weight. It contains proteins that is required in metabolism of the collagen, tyrosinates, and catecholamines. Ayan. Iron has multiple effect in the cell-mediated immunity. Ayan, so pagde-develop ng ating pong mga cells that are important in combating diseases and microorganisms. So, paano po sila tumutulong sa cell-mediated immunity? They modulate the propagation of the differentiation of lymphocyte subsets. Ayan. So, tumutulong po ang ating pong iron para mag-mature, para magtuloy-tuloy ang cellular differentiation ng ating pong mga lymphocytes. They also help by affecting the immune potential of the macrophage. Ayan, alam naman po natin ng mga macrophage, ito po yung mga white blood cells natin na isa lang ang ginagawa nila, kinakain nila, 'di ba, ang mga antigens o yung ating mga foreign bodies, okay, o yung mga microorganisms na hindi kailangan sa katawan natin. Iron distribution in the body. So, we have the red blood cells. Ayan, kapag gusto mo makita yung iron sa red blood cell, tingnan mo yung hemoglobin. Pwede rin po siya na nakatago, di ba? Kagaya na nabanggit natin kanina, yung sobra-sobrang iron, itatago po sa ferritin. Okay? And hemosiderin as a iron store. Body tissues containing the iron, so lalong-lalo na po sa ating po mga muscles, such as that of the myoglobin. Iron may also be found sa transferrin, di ba na? Para po mag-travel siya papunta sa iba-ibang mga body parts, transferrin. As you can see in the picture, makikita po natin dito yung mga body distributions ng ating pong iron. Myoglobin, ferritin para itatago. Ang ferritin po natin, majority, makikita natin yan sa liver. So, meron din tayo sa transferrin, So, kung saan po ang test, okay, na i-determine natin kung gaano kadaming transferrin ang ma-accommodate yung iron that is bounded to transferrin is your total iron binding capacity. Then we also have the presence of the iron that is in the red blood cells through hemoglobin content. Ayan, Iron metabolism and regulation. So, dietary iron has to be in ferrous form in order to be absorbed. So, nabanggit natin kanina na isa sa mga reason kung bakit nagkakaroon tayo ng deficiency is baka meron kang problem doon sa absorption mo. Ayan, So, pagdating sa iron, meron tayong napaka-importanting mga charges, di ba? Yung ating pong positive 2 charge at saka positive 3 charge. Ayan. So, yung ating pong ferrous form o yung iron in positive 2 charge, kailangan yun na ang ating pong gagamitin para ma-absorb siya sa katawan natin. Ano pang importante? Ascorbic acid. So, yung acidic pH ng stomach, yan, isa pang reason or isang magandang factor para ma-absorb yung ating pong iron sa katawan. Along with the presence of the reducing substances, may also enhance iron absorption. So again, para ma-absorb, kailangan po yung ferrous form o yung iron positive 2 form sa katawan natin para ito ay ma-absorb sa ating pong stomach. So, once it is absorbed, it will be transported by the plasma transferrin. So, alam na po natin na nagtatransport ang ating pong transferrin. Ferritin will provide accessible reverse of the iron for the synthesis of iron-containing compounds. So, nakita po natin kung gaano po ka-importante yung pag-absorb ng ating pong iron in the form of Fe positive 2 and also the presence of the acid or yung ating pong acidic pH, yung po pagdagdag natin ng vitamin C sa iron, will enhance the absorption of our iron. So, yun ang importante. Now, let's talk about the clinico-pathologic correlations that involve iron. Iron deficiency. So, this is a deficient in a total body iron o kakulangan po sa ating pong iron. First, we have the iron depletion. Ayan, ito po yung earliest stage ng iron deficiency. So, at this stage, the storage of iron is decreased or absent, but the serum iron and hemoglobin concentration are preserved. Ayan. So, ito po yung unang stage ng ating pong iron deficiency. Next, we have iron deficiency without anemia. This denotes additional decrease in the iron storage that may limit the heme production but without frank anemia. So, wala pa itong anemia. Further decrease lang po sa iron storage. Then we have the iron deficiency anemia, which is the most advanced stage. So this is the most common cause of anemia and it is also occurring in worldwide. What are the major causes or reasons for iron deficiency? Blood loss. Ayan, ne? So, pwede pong mga iba-ibang factors, ne? Kagaya po ng it may be due to accident, ne, na blood loss. What else? Chronic drug ingestion. So there are some drugs ne, that would affect the red blood cells. Ne? So pangalawang reason yan kung bakit nagkakaroon ng iron deficiency. Hookworm and helminth infection. Ayan. So kung nakikita po natin, ibang klase yung mga suckers, di ba? Yung mga oral suckers, ventral suckers ng ating pong mga hookworm and our helminths. So this would also lead to iron deficiency. Impaired iron absorption, just like what we have discussed previously, kung saan po yung mga possibly yung ating pong iron, hindi siya na-reduce doon sa ating pong ferrous state. Ne? So kahit na may iron ka, pero hindi siya na-reduce into ferrous state, hindi siya maa-absorb sa katawan mo. Or possibly, kulang pa sa acidic pH yung environment ng gastrointestinal system mo. So, possible na magkakaroon ka pa rin ng impaired iron absorption.